When we have a function of two variables, we have seen that we can differentiate it partially with respect to one of the variables holding the other fixed, and then we can take this result and differentiate it once more with respect to the other variable. Just as we can do differentiation with respect to the two variables separately one after another, we can also do integration. First, say we integrate with respect to x holding y fixed, and then we take this result, which is now just a function of y, and integrate it with respect to y. When we do one integration after another, this is called iterated integral. When we are doing the inner integral, in this case with respect to x, we are treating y as fixed, so we might use y even in one of these two endpoints or maybe in both the endpoints, like this. Let us take a look at computation of one such iterated integral with an example. In this example, the inner integral is with respect to y. Let's do that. Here we are considering x as fixed, so x remains just a constant. Y square integrated produces 1/3 y cube, y produces half y squared. Once you put the two ends, you get this, and then you carry out the integration as usual, you get whatever answer you get. It is instructive to think of this geometrically. I have a function of two variables, so you can think of it as a surface over the xy plane. So the surface is floating in space. Now this actually defines a region in the xy plane. Start from the outside integral with respect to x. X goes from 0 to 1. I will mark that region here, 0 to 1. Now, when x is going from 0 to 1, for each value of x, y goes from 0 to x squared. So, let's just draw the curve y equal to x squared, and then y goes from 0 to x squared, and x itself is moving from 0 to 1. So, we are actually integrating over the region that I have shown by shading. So what is meant is the following. There is a surface of this particular function, and you consider a tent. The tent has this as the floor and that undulating surface as the roof. You are finding the volume of the tent. So this thing is lying flat horizontally on the xy plane, and that is the surface. I've just drawn some arbitrary looking surface for this function. Now you are considering your tent, which has walls like this, and you want to find out the total volume of that tent. This is what this thing is doing for you. Now in this example, we found this volume by first integrating over y, then integrating over x, and we are basically doing it like vertical strips, and the vertical strips are moving from 0 to 1. We could have done it the other way around, first over x and then over y. Let's see how that works. Then we'll first see how much y changes. Y goes from 0 and it goes maximum up to 1. So it is from 0 to 1, but now the integral is with respect to y. And what happens to x? Once you have fixed a value of y, x runs in this range. So you know what y is. From that you can work out the value of x, and that will be positive root of x, and it goes on up to 1. So I will put positive, I know the value of y, I am sorry, I wanted to say positive root of y, positive root of y to 1. So if I carry out this integration, again I should get the same answer, namely the volume of the same tent. The natural question is the swapping of integrals, whether I do x first or y first, that is always allowed, it doesn't matter? Well, there are pathological examples where it will matter. The two answers will be different. But for most cases, it will not matter. In particular, it will work for non-negative integrals. I should say non-negative integrands. So if this integrand is non-negative over the region where you are integrating, then swapping will not have any effect. And there are a larger class of integrands for which also swapping will not have any effect. And these things, so all these conditions under which the swapping has no effect is called Fubini's theorem, that you are going to see the proof of in some later course. But for our course, we will only work with those integrands for which the order will not matter. In this exercise, your job is to find out this integral. I have deliberately written it in this way. So this means your tent roof is given by this function x plus y square, and this is the region which is the roof of the tent. And you are supposed to turn it into an iterated integral. You have to decide whether you want to do x first or y first. So you just turn it into something where you do x first and then you do y first, decide about the appropriate endpoints and work it out, then do it the other way around. First integrate with respect to y and then with respect to x, and again work it out. You should get the same answer by Fubini because this is non-negative over this region. So just check whether you are getting the same answer.